Installation, testing, operation and maintenance of a Lennox air-cooled chiller. Installation. 1.1 Layout and installation requirements. Air-cooled chillers with helicoids fans such as Ecologic or Neosys are designed for outdoor installation. Please consult Lennox prior to implementing other types of installation. Locate the chiller where it is least affected by wind. Install windbreaks where wind speeds 2.2 ms. The ground beneath the unit must be flat, level and of sufficient strength to support the weight of the unit with its full liquid charge, and the occasional presence of the usual service equipment. In locations exposed to frost, the supporting surface, if the unit is installed on the ground, must be built on concrete stakes extending downwards beyond the normal depth of frost. It is always advisable to build a supporting surface detached from the general building structure to avoid transmission of vibrations. On normal applications, unit rigidity and point load positions enable installation to minimize vibrations. Vibration isolators may be used by contractors on installations requiring particularly low vibration levels. It is essential that the units be installed with sufficient free space around them to enable proper circulation of air ejected by the condensers and to provide easy access to all unit components for servicing and maintenance. If the air rejected by the condenser encounters any obstacles, to prevent airflow to be reversed due to prevailing winds, units cannot be completely shrouded with a higher, uninterrupted windshield. If such a configuration cannot be avoided, an air ejection duct must be installed at the same height as the surrounding shield. Fig. 4. Proper installation of the unit. 1.2 Water connections. The water circulating pump will be preferably installed upstream so that the evaporator condenser will be subjected to positive pressure. Entering and leaving water connections are indicated on the certified drawing sent with the unit. The water must be analyzed. The water circuit installed must include all items necessary for treatment of the water: filters, additives, intermediate exchangers, bleed valves, vents, isolating valves, etc. Depending on the results of the water analysis. The glycol water solution must be sufficiently concentrated to ensure proper protection and prevent formation of ice at the lowest outdoor air temperatures expected on an installation. Take precautions when using non-passivated MEG antifreeze solutions, monoethylene glycol or MPG monopropylene glycol. To enable drainage of the circuit, make sure that drain cocks are installed at all the low points of the circuit. To drain the circuit, the drain cocks must be opened and an air inlet ensured. The minimum volume of the chilled water circuit must be calculated with the formulas hereunder. If necessary, install a buffer tank. Proper operation of regulating and safety devices can only be ensured if the volume of water is sufficient. A flow switch must be installed on the evaporator water inlet or outlet, so as to enable detection of water flow through the heat exchanger before the unit is started up. This will protect the compressors against any eventual liquid slugging during the starting phase and prevent accidental ice formation in the evaporator, if the flow of water is interrupted. 1.3 Electrical connections. First of all, make sure that power supplies from the building to the place where the unit is installed are properly established and that wire gauges are in keeping with the start-up and running currents. Check tightness of all electrical connections. You must make absolutely certain that the power supplies applied to the power and control circuits are those for which the electrical panel was manufactured. A main isolator switch must be inserted between the end of the power supply cable and the unit to enable total isolation of the latter when necessary. Chillers are supplied as standard without a main isolator switch. This is available as an option. 1.4 Sound levels. Liquid chillers are a significant source of noise in refrigeration and air conditioning systems. Account is taken of technical constraints, both in design and manufacturing. Sound levels cannot be improved much further than specified. Sound levels must therefore be accepted for what they are, and the area surrounding the chillers should be treated as necessary. The quality of installation can either improve or decrease initial sound characteristics. it may be necessary to provide further treatment such as soundproofing or installation of screens around units installed externally. The choice of the location for the installation can be of great importance: reflection, absorption, transmission of vibrations. The type of unit support is also very important. Inertia of the room and the structure of the walling interfere with the installation and its behavior. Determine what level of soundproofing is necessary on the equipment, the installation, silencer, vibration isolators, and screens, and on the building, reinforcement of flooring, false ceilings, and wall coverings. 1.5 Ducted units installation. Notes: be careful of air cycling between inlet and outlet. For air outlet, it is recommended to duct each fan separately. Testing. Procedure to follow when starting a unit. 1-A. Press the power on/off switch. The compressor will only start if the evaporating pressure is greater than the cut-in set point of the low pressure switch. Check immediately the good rotation of the compressor. Evaporating pressure drops steadily. The evaporator empties itself of the liquid refrigerant accumulated in it during storage. After a few seconds, the solenoid valve opens if any. 1-B. Check on the sight glass, upstream of the expansion valve, that the bubbles disappear progressively, indicating a correct refrigerant charge and without non-condensable gas. If the humidity indicator changes color, indicating the presence of humidity, replace the filter dryer cartridge if the latter is of the replaceable type. Checking the subcooling after the condenser is recommended. 1-C. Check that, when the cooling load has been balanced by the capacity of the unit, the chilled liquid is at design temperature. 2. Check the current values per phase on each compressor motor. 3. Check the current values per phase on each fan motor. 4. Check compressor discharge temperature. 5. Check compressor oil pump temperatures, semi-hermetic reciprocating compressors. 6. Check suction and discharge pressures and compressor suction and discharge temperatures. 7. Check chilled liquid entering and leaving temperatures. 8. Check outdoor air temperature. 9. Check liquid refrigerant temperature at the condenser outlet. Unit operation. 1.0. Functions of refrigeration circuit components. Thermostatic expansion valve. The thermostatic expansion valve fitted on each machine has been selected for a given operating range. It must be replaced with a model with the same reference from the same manufacturer. Filter dryer. This is designed to remove all traces of humidity from within the refrigeration circuit, since this can impair operation of the unit by acidification of the oil, which causes slow disintegration of the varnish protecting the compressor motor windings. High and low pressure gauges, sight glass humidity indicator. Enables visual verification of the state of the liquid refrigerant, monophase or diphasic, in the liquid line, upstream of the thermostatic expansion valve. Enables detection of humidity in the circuit. Crankcase heater. Every compressor is fitted with a single-phase crankcase heater that is activated when the compressor stops to ensure separation of the refrigerant and the compressor oil. It is therefore powered up when the compressor is not running. High pressure switch. This pressure switch initiates unconditional stoppage of the unit if compressor discharge pressure exceeds the operating limits. Reset is automatic. Screw and reciprocating compressor with R407C high pressure switch equal 26.5 bars. Scroll compressor with R407C high pressure switch equal 29 bars. Fan control pressure switch and thermostat. The function of these devices is to ensure a level of head pressure compatible with proper unit operation. An increase in outdoor air temperature increases head pressure, and this is maintained at its required value by fan operation. Antifreeze function. This function only exists on units designed for brine or glycol water chilling, for which the freezing temperature depends on the concentration of the solution. Whatever type of device is used, see case 1 and 2, cut out by the antifreeze function causes immediate unit stoppage. Case 1, antifreeze thermostat. This device monitors chilled liquid temperature at the evaporator outlet. It triggers when the temperature goes below the minimum value, plus 4C for water. Case 2, antifreeze pressure switch. This monitors evaporating pressure of the refrigerant. It triggers when the temperature goes below the preset minimum value. 1.1 Functions of electrical components. Electronic Ocam type anti-short cycle relay. This device limits the number of compressor startups. Compressor motor thermal protection. This device stops the motor if winding temperature rises too high and enables it to start up again when temperature drops back to a normal value. Fan overcurrent protection. Circuit breaker designed to stop the fan motors in the event of phase overcurrent in relation to the permitted value. Compressor motor overcurrent protection. Circuit breaker designed to protect each motor winding against accidental overcurrent. Indicator lights. The electrical control box is fitted with indicator lights enabling visualization of the state of operation or non-operation of a function or given circuit. There is also an indicator to show that the unit is powered up, an emergency stoppage indicator for each compressor, an indicator to show stoppage of the compressor via the regulating system, through the main control thermostat which is sensitive to chilled water temperature, a run light per compressor, and a general fan default stoppage indicator, on air-cooled units. Chilled liquid pump interlock. This interlock is made only if the pump is supplied with the liquid chiller. As soon as the unit is powered up and the remote on-off for the unit is validated, the pump starts running. Prior operation of the pumps is mandatory for compressor operation. Flow switch for the chilled liquid. This control device initiates unconditional unit stoppage as soon as the flow of chilled liquid, water, brine, etc., ensured by the pump becomes insufficient, since this could cause rapid evaporator freeze up. When the contact opens due to a lack of flow, the unit must stop immediately. 1.3 Automatic sequences. Starting sequence. Press the unit start switch, the power light will come on. The control circuit cannot be energized if there is no power supply to the main power circuit. Depending on the demand for cooling, the control thermostat authorized startup of the compressor, S, which takes place in sequence. The compressor run indicating lights come on. Regulator stoppage sequence. When the cooling load starts decreasing from its maximum value, the multi-stage control thermostat shuts down successive stages depending on the progressive reduction in return chilled liquid temperature. Depending on machine equipment, staged reduction consists either in shutting down a compressor or activation of a compressor capacity reducer. This continues until the unit shuts down completely through action of the regulator. The compressor regulation stoppage lights come on. Safety shutdown sequence. If a default occurs on a circuit, it is detected by the appropriate safety device, high pressure overshoot, loss of oil pressure, motor protection, etc. The relay in question initiates unconditional stoppage of the compressor on that circuit and the safety stoppage indicating light comes on. Loss of power supply. There are no problems restarting the machine after a loss of power supply of short duration, up to about 1 hour. If loss of power supply lasts longer than this, when power supply is resumed, set the unit to off with the compressor crankcase heaters activated for as long as it takes to bring sump oil back up to temperature, then restart the unit. Condensing pressure controlled water valve. This device is available as an option for low-capacity water-cooled condensing units, MCW. The high-pressure controlled water valve should be installed on the condenser outlet. It enables water flow through the heat exchanger to be varied so as to maintain condensing pressure at an appropriate value. Maintenance. 1.0 Weekly maintenance. 2. Overcharging with oil can be as dangerous to a compressor as a lack of oil. Before topping up, contact a qualified technician. Only use oils recommended by the manufacturer. 3. Check the oil pressure. 4. The flow of liquid refrigerant through the sight glass should be steady and without bubbles. Bubbles are a sign of a low charge, a possible leak, or of a restriction in the liquid line. Contact a qualified technician. 5. Check operating pressures. If they are higher or lower than those recorded when the machine was put into service, see the Chapter 8. 6. Inspect the entire system so as to detect any eventual abnormality, noisy compressor, loose casing panels, leaky pipes or juddering contacts. 7. Record temperatures, pressures, dates at times and any other observations in the service log. 8. Leak detection is recommended.